Hello everyone, and welcome to today's presentation. My name is Kevin, and I'm a Director of Sales Engineers for LTS. It's my pleasure to speak to you today about the very cutting edge of video surveillance technology, which we refer to as DeepVision. First, we'll take a look at some of the common pain points of traditional video surveillance and the trends that have brought us to the current day, as well as the ways that DeepVision can help solve these typical hurdles of video surveillance operations. By the end of today's presentation, you should have a strong idea of just what DeepVision is and what it does, and how it could be beneficial to you as well as to your customers. In addition, we'll perform a real-time demonstration of this technology together. I want to thank you once again for your attendance today, and let's waste no time in getting started. Traditional video surveillance comes with challenges that we've been attempting to overcome as long as the industry has been around. There are several more that we could name, but we can see some of the most common and difficult ones listed here. Finding a particular target in a crowded environment is no easy task. We often have minimal descriptors of a person or vehicle, while simultaneously having a broad span of time or a large number of cameras to review. Manually reviewing video can be challenging, inefficient, and it becomes more challenging and more inefficient as we add more cameras and more time into the equation. Complexity in operation can inflate the amount of time it takes even further. Each of these pain points takes us further and further away from the time of the event, delaying results when they may be crucially needed. Over time, various technology trends have allowed us to reduce the amount of time it takes to find footage when we need it. In the most basic form, we have traditional manual processes. These include fast forwarding through video to find an event, using slice or interval playback to narrow down the time frame of an event, or by searching with basic motion detection events, which oftentimes provides a large number of false positives. Motion detection searching eventually led us to human and vehicle-based motion events, helping with these issues tremendously, but we can do better. As onboard analysis improved and the inclusion of AI became more prevalent, we moved into the ability to direct search. We'll discuss direct search in more detail on the next slide, but the key takeaway here is the ability to implement small-scale AI model searches by picture in order to find targets right on the recorder. The natural progression of this technology has led us to DeepVision, which takes things a step further into large-scale AI model searching that searches not by picture, but by simple semantics, using common language. In the past, cameras could collect basic data on motion detection, but now they can collect much larger amounts of relevant metadata. This metadata can be analyzed by recorders with direct search capabilities. As we see in the example image, this allows the recorder to detect people or vehicles in the frame. Then, by clicking on the magnifying glass, we can perform a search for targets that resemble the selected target. This allows us to quickly find results across multiple cameras and for large periods of time. Once a target is located, we can get results in seconds related to the other places they've been, potentially saving hours of scrubbing through various video streams. But still, we must identify our subject of interest in the first place, which brings us back to some of the pain points that we discussed earlier, and ultimately to today's main subject, DeepVision. DeepVision uses specialized hardware to process camera metadata in a fundamentally different way, allowing us to interact with video playback like never before. It uses what can be referred to as a cross-modal AI, or a type of artificial intelligence that, in this case, enables interaction between two different data types, text and images. So how do we interlink these two? Well, it starts with the cameras. When a camera detects a person, vehicle, or other target, its image encoder analyzes the scene, then sends that structured data to the DeepVision NVR. At this point, the NVR is not only storing the raw video, but also the advanced metadata that accompanies it. This means that both the camera and the recorder have to be capable of performing these functions, but it also means that we are now capable of using text to interact with video data. We can refer to this function as semantic search. When you enter a keyword or phrase, such as person wearing a pink shirt, the NVR's built-in text encoder will convert your text search into the same type of embedded data as the camera. Then compare that data against the stored data. Because your text and the recorded video are represented in the same semantic space, the NVR is able to quickly find the most relevant results. You'll notice by default that the results are listed with the highest percentage first. This percentage is a representation of this data comparison and can be considered a threshold of confidence. In our first example image, the NVR is 90% confident that the image contains a person wearing a pink shirt, and so on for the rest of the images. There are a few best practices to consider when using semantic search, but the overall process is simple. If you can use a search engine, you can use semantic search. As we can see on the slide, the basic formula is an adjective plus a target. An adjective is a word that describes or modifies a noun or a pronoun, or in this case, a human or vehicle target. Adjectives come in several types, but we'll mostly focus our searches using physically descriptive adjectives, such as color, shape, or appearance. Simple keywords can also be used, but multiple descriptive adjectives help to quickly narrow down search results, allowing us to find, for example, a man wearing a blue shirt and dark pants across multiple cameras. One thing to keep in mind, though, is that DeepVision inspects one frame at a time, meaning we want to avoid searching for actions that may take multiple frames to accomplish, such as running, jumping, or throwing. We also want to avoid searching for negatives. For example, we would expect to see better results when searching for people wearing hats, rather than searching for people not wearing hats. Next, we'll watch a quick video of how DeepVision performs an action, which is accessible on our YouTube at any time for later reference. Then we'll go through a quick live demonstration together. So the video does a great job of demonstrating very quickly some of the various features of DeepVision, but we're going to slow things down just a little bit and go ahead and do a live demo through the interface together. So of course the first thing that we're going to need to do is go ahead and log into the recorder. If you've been familiar with Platinum recorders, you're going to find that this interface is ultimately not all that different. There are no large changes to be made here, except we can see on the left-hand side menu in the configuration that we now have a DeepVision option. By clicking on this, it's going to take us straight into our DeepVision searching. As we can see here, starting from the upper left and working our way right, we're going to have already some common categories that have been put in here for us, such as favorites, if we choose to save favorites over time, suggestions that are built in for us, person, vehicle, and non-motor vehicle. And we're going to touch on each one of these very briefly. Favorites, of course, would allow us to save terms into favorites to allow us to quickly come back to them in the future. Suggestions are going to be particular suggestions that are already built in. If you're not really sure how to use the system, this is a great way to get yourself familiarized, and one of the first things that we'll go ahead and search for. For example, under behavior, we can go ahead and click on talk on the phone, and it's going to automatically put in there for us person talking on the phone. We can change it after we do the search, or we can change it right now. to different common time periods, such as 1 day, 3 days, 7 days, or even allow ourselves to put in a customized period of time. I'm going to go ahead and open this up to 7 days and search. As we can see, it's going to very quickly populate for us a number of results, even though we're looking over 7 days worth of video. Starting from the top left and working its way right, just like we would read, we're going to see that the percentages start at the highest percentage of similarity first and descend from there. Near the center top of your screen, you're going to see a similarity threshold slider. The further to the right we move that slider, the larger the number is going to go, and the higher or more accurate our results rather must be in order to be populated. The further to the left we send this similarity slider, the wider range of values we're going to allow as far as accuracy goes. But as we can see, these top results in this case have done a very good job for us, populating a large number of images of people talking on phones. So let's go ahead and continue down the line in looking at some others. Jumping into the person section, we can see here that it's divided up by a bunch of common categories such as tops, bottoms, accessories that they're wearing, behaviors, and these may be divided up into different colors, such as for the tops and bottoms. For the accessories, they may be things such as hat, glasses, or handbags, or backpacks, and behaviors could be things like riding a bike or pushing a baby stroller. Again, you can search for all of this as you please just by typing it in. However, a lot of this is already going to be built in here for you. So let's go ahead in our case and take a look at handbag. Let's search just for today and see if we get any results of people carrying handbags. And yes, we do. We have quite a few, and we could even probably broaden that out if we wanted to by searching for 7 days rather than just today. And of course we do. The thing to keep in mind is as the degree of confidence lowers, as our percentage lowers and lowers, that doesn't necessarily mean that our results are going to be worse, but there may be less metadata overall on the image to help us really determine that there is a handbag. So there may be something that looks like a handbag, but isn't, or we may not just have enough pixels on target to really make a determination that that is a handbag for sure. But as we can see here, the results that we're getting overall are doing very well. Doing a little bit more searching into the vehicle category, we can see things again sorted for us already by things such as type of vehicle, like trucks or station wagons or buses, or brand, such as Audi or Honda or Tesla. So in this case, let's go ahead and look for some Teslas over the last 3 days. Now keep in mind, this is a general search. This is just for a Tesla vehicle, but if I wanted to take this a step further, I could always look in particular for, let's say, a white Tesla vehicle and search by that. As we mentioned earlier, the more adjectives or descriptive adjectives that we can really provide, the better off we're going to be. So we can see we can narrow down some of those results by putting in a color value as well. Finally, coming to non-motor vehicles, we can see this again split into some common categories such as bicycles, motorcycles, or scooters. However, I am not going to look for any of those today because I know for a fact we haven't seen any bicycles, motorcycles, or scooters. So we're going to go ahead and skip that and go into something a little bit more interesting. So we don't just have to search by the commonly defined fields that are already here for us. We did see one in the beginning, such as a person talking on a cell phone, which is a very useful metric for us. Another one that we may want to look at is something like a wet floor sign. So I want to look for a person with a wet floor sign. If I had an incident the other day wherein someone got hurt, I may need a quick way in order to look that up. So I'm going to go ahead and open this up to the last 7 days. And as we can see here, some of these very first results that we're getting indeed are someone carrying a wet floor sign, and several more results from there. Let's take it to one more interesting example, and then we're going to talk about how this ties directly into the direct search option as well. Please forgive my typing. So, in this case, I want to look for a person with a racket. Now, as we can see, I've got a good identification of this person. However, I would like to know where this person has been other than this particular location. By clicking on the image, it will go ahead and load up the video that's associated with this particular event on the right-hand side, and we'll get to see the person come into frame that caused the event to happen in the first place. So let's say I want to take this a step further, and I would like to see where else this person with the racket has been. By clicking on the direct search button, located just beneath the video frame, it's going to go ahead and pop that frame open for us to a larger extent, and we're going to see that it's highlighted both of the people that are located within the video. However, the only one that I'm concerned with is the person with the racket. So I'm going to go ahead and click on the magnifying glass next to the person with the racket, and it's going to perform a secondary search. You'll notice on the left-hand side that we're looking through all of the cameras simultaneously. Start time and end time are just over a 24-hour period. However, just like before, we could also open this time period up to be more than just a day if we so chose to do that. As we can see now, we get several more results, not just looking for people with rackets, but for specifically the person that we identified with a racket that came in the first place. What makes this great is now we could either sort by similarity or we could sort by time. This will give me an idea of where this person has been within my facility over time and across multiple cameras. Now that we've looked at a video demonstration and live demonstration, we'll return to our presentation in order to close things out. It's important to remember that all of the encoding and searching is being done by the recorder itself, meaning that no connection to the internet is necessary and no cloud-based processing is happening. This allows us to bring this feature to a variety of NVRs and keep the overall bandwidth requirements low. When looking at NVR model numbers, keep an eye out for DV in the model number. This is a quick identifier that the recorder supports DeepVision, but you can always check the spec sheet for more information. The 8-channel model, provided the cameras support it, can support up to 8 channels of direct search and DeepVision, but you'll notice the slide also mentions 8 channels of face recognition. This is a good opportunity to clarify the limitations of the current DeepVision recorders. On board each DeepVision recorder, we will find 2 analytical engines. These engines are responsible for gathering and analyzing the metadata provided by the cameras. As with any computer, resources are finite, so we have to make a choice. We can either use the engines for direct search and DeepVision, or we can use them for face recognition, but we cannot use all of these features simultaneously. In addition to the 8-channel model, we also offer a 16-channel model. As with the 8, this NVR is capable of DeepVision and direct search on all channels, but can only provide face recognition on up to 8 of its total channels. And finally, we have our 32-channel model. Again, this supports DeepVision and direct search on all of its channels, or up to 8 channels of face recognition. You will also notice that decoding capacity has increased with NVR channel count, as well as the number of hard drives that are supported. In terms of which cameras are able to provide the metadata required, the good news is that there is a large list, as we can see here. We won't review every model in detail today, but the need-to-know information is as follows. Compatible cameras are available in a variety of resolutions, form factors, and lens styles. If you're looking for a particular camera type, odds are we have one that supports DeepVision. The firmware of the camera should be paid attention to as well. Ensure that the firmware build of version 5.7.17 or better is being used, though for some cameras, as we can see, any firmware will be supported. If you're ever trying to determine at a glance whether the camera supports DeepVision, the key spec to pay attention to is VCA 2.0. If the spec sheet lists these functions, that's a strong indicator of its compatibility. It's always good to keep in mind, though, that new models will be introduced and some models will reach end of life over time. So if you're ever unsure, please reach out to your local sales team member and they would be happy to assist you. While there will be an open Q&A section shortly, I did want to cover a few frequently asked questions prior to this segment. Let's start with, can I search for person and vehicle targets only? The answer here is no, but with some caveats. DeepVision is designed primarily for human and vehicle targets. So while you can create prompts that don't involve these targets and it will attempt to produce results, the odds of a successful result will be much lower than those involving human and vehicle targets. For instance, we expect to see more accurate results when searching for a person with a dog rather than just a dog. Next, will DeepVision improve over time? The short answer here is yes. However, DeepVision does not self-train, meaning that algorithm improvements over time will be instituted by firmware updates and not by self-training in the field. And finally, can semantic search only be used with the web interface? As of the time of this recording, only the web interface and local GUI are supported. However, in upcoming versions of LTS Connect, our mobile app, and XVMS, our enterprise VMS software, semantic search functions will be made available, providing the ability to semantic search simultaneously across multiple DeepVision NVRs on local or wide area networks. As we bring today's presentation to a close, I would like to point out just a few of the applications where we know this technology will flourish. As we've seen, with just a few keywords, DeepVision can help quickly locate people and vehicles, whether they're known or unknown. Searching for events have never been easier, and working in tandem with direct search helps push the ease of use even further. From retail environments to warehouses, public parking lots, and office spaces, DeepVision can use simple semantic searching to find the results you need when you need them. Once more, my name is Kevin, and I want to thank you for your participation today. I hope you found this presentation to be informative and ultimately has you thinking about just how you can implement DeepVision into your projects in the future. At this point, I'll hand the microphone back off to Joel to continue with today's presentation. Thank you so much. I appreciate your time.